So in our note 6.4 here, we are looking at applications of systems of equations. Yes, we're looking at word problems. So they're giving you word problems here, and our essential question is, can I choose the best method for solving a system of linear equations? So let's go ahead and take a look at problem 1 here, and this is finding a break-even point. So a fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Well, first of all, I want us to remember we're looking at and dealing with systems of equations here. So we need two equations. It's the first thing we've got to figure out is we've got to decide on two equations here. Before we even decide on those equations, let's think about what do you think our x and our y is? So what could our x be here? Well, our x is probably going to be the number of hats that we're selling, right? So the hats sold. Let's think about what you think our y could be for these equations. The money, the income, or the expenses, right? The expense or income. So let's think about, I like this, the hats sell for $12.50 each. So if we were selling hats for $12.50, how could we write that equation? How can we find out how much money we're going to make depending on how many hats we sell? I think that's the easiest one to write. It's just y equals $12.50 times x. So we have y equals 1250x. What does that mean? That means $12.50 times every hat you sell. If we sell 2, we times it by 2. If we sell 400, we times it by 400 and we find out how much we make. But remember we had like upfront cost. We had to spend $1,400 on advertising. And we know that it cost us $5.50 for the material. So we got to break even here. If we've already spent $1,400, we got to sell quite a few hats to break even. How do you think we could write our second equation? Well, our second equation, we've already spent the $1,400, and we're spending $5.50 per hat that we sell. That's how much the material cost. And that would be our total expenses, y. So the next thing, step 1 is to determine these letters and what they stand for. Step 2 would be to write the two equations. Remember, systems of equations means we have to have two. Now step 3 would be to solve. And so here we're talking about the application, or what method are we going to use to solve? So let's talk about the method. What method would you use here? Well, in both of these equations, I see the variable y, which is a coefficient of 1, equals. So this to me is a no-brainer. I would definitely use substitution. I wouldn't want to use graphing because you'd have a y-intercept of 1,400. And no need to use elimination because you would just have to rewrite. Yeah, let's just not do that. Let's just substitute. So I would circle 1 and I would substitute it into the other equation. And we could find out how many hats we have to sell to break even. Remember, we already spent that $1,400. I'm going to let you finish the problem. We'll talk about it in class. Let's go write the equations and then choose the best method in order to solve. Have a good one. The last one was kind of set up as our y equals, more in slope-intercept form. I think this one's actually easier to set up personally. But a student bought 3 boxes of pencils. I'm going to underline my important information here. And we know 2 boxes of pens for a total of $6. He then bought 2 boxes of pencils and 4 boxes of pens for $8. Write a systems of equations that you could use to solve. Solve the system to find out how much did it cost for each box of pencils and pens. Let's think about our variables here. What is going to be important in this problem? Well, our pens and our pencils, or pencils and pens. So because of our pencils and pens, we need to think of letters for those. Let's just go ahead and do X for pencils and Y for pens. I wrote that so we would remember which is which. So remember, it is a system of equation, meaning I'm going to have two equations here. Let's go ahead and set it up. It's kind of set up for you in the writing if you go through and read it sentence by sentence. 3 boxes of pencils, that's 3 times X. We don't know the cost of them yet. And, so in addition, plus 2 boxes of pens equals $6. That's how much it cost. That would be equation 1. And then equation 2 would be 2 boxes of pencils. Remember, pencils we said was X. And 4 boxes of pens is $8. So this is more in standard form. What method would you use here? So the first method, or the first step, we identified our variables. The second step, we wrote our equation. And now let's think and talk about our third step. How would we go about solving this? All my letters have a coefficient bigger than 1. I'd probably use elimination. So we could use the elimination method. You could also probably graph these maybe by using your X and Y intercepts to help you graph for each of these because they're each divisible easily. You could find those easily. But if we use elimination, we would just have to get, I'd probably multiply this top equation by 2. So we have 6x plus 4y equals 12. Remember, everything is multiplied by 2. And then we have 2x plus 4y equals 8. And in order to solve, you now have your letter y's have the same number in front of them. So a 4 plus 4 would be 8. We don't want to do that. Remember, we want to get 0. We want to eliminate. So we would subtract. So go ahead and finish this problem. And let's look at one last problem. Is being able to take these word problems. This is a reasoning problem, and it's just saying which method would you use to solve the systems of equations and explain. So we have our graphing method we could use. They're not in slope-intercept form. The x and y intercepts would be a decimal. Graphing is usually not my personal go-to method. I don't have any of my x or y's that have a coefficient of 1. So substitution for me would probably be out. So the next best method would be elimination. My x and my y's, I'm going to have to multiply. I'd probably multiply the top one by 2. We'll have to multiply the bottom one by 3. So we would have, on the top, we would have 6x plus 4y equals 18. And in the bottom, we'd have negative 6x plus 9y equals 15. You have a 6x and a negative 6x. In order to eliminate those, you would have to add to get 0. And go ahead and solve for x and y on these. So elimination, but we are going to have to multiply, and we're going to actually have to multiply both equations in order to get the coefficient x the same. So this